Hey there, so now we're going to talk about protocols. Welcome back. You know, protocols don't provide any implementation at all. All they provide is a blueprint of methods and properties and other requirements that suit a particular task, things that you need to fulfill when writing your code. But for doing that, they are actually pretty cool. The protocol doesn't actually provide any implementation at all for any of the requirements. All it does is describe what must be implemented and what that implementation will look like. So protocols can then, once they're described, they can then be adopted by a class, they can be adopted by a structure, by an enumeration, an enum, and then those enum structures and classes will provide the actual implementation of those requirements. And then any type that satisfied those requirements of the protocol, it's said that they conform to the protocol. That's how you say it, conforming to the protocol. So let's just create a protocol really quickly. You're going to see that a protocol looks very similar to a class. To be creative, we'll call this my protocol. And you'll see that we use a capital M, and we just write protocol the same way that we would write class or struct or enum. You just write protocol. And then the protocol definition goes in here. Now that's actually a valid protocol. As you can see, we don't get any errors. When you want to adopt a protocol, all you do is you create the class, adopter class. Now you don't usually write class at the end. You do the colon as if you're inheriting something, but you're going to just write my protocol there. And then you do the open and close curly braces. So at this point, this class does adopt and conform to this protocol because this protocol doesn't have any requirements at all. So let's create a requirement for this protocol. We're going to create a protocol called my protocol. We're going to say that this protocol needs to have some property, and that property needs to be a string. And in these closing and opening curly braces, you just need to say whether it's a getter or a setter or both. Can it be read? Can you do something like, if you're inside the class, that would be reading the property, that would be the get. And then can you assign it? Can you say some property is equal to hi there? That would be the setter. That would be writing to the property. So in this case, we're saying that some property can be written and can be read. Obviously, you can't have just the writing. You have to have the reading and the writing together, or just the reading. You can't have just a set by itself. You have to have at least the get and the set together, because it doesn't make sense to write to something that you can't read. So now we are getting an error because this class does not conform to the protocol my protocol. In order for it to conform to that, we have to write var some property is a string. And now we're getting an error because we don't have an init function. So if we were to do an init function, some property is a string, and then here we would write self.someProperty is equal to some property. Now at this point, the adopter class does conform to this my protocol. So the protocol sets the requirements for a property name and type. And then if you want the property to be settable or gettable, then you use the set and get keywords. And we said that obviously you can't have a property with just a setter. So let's make a protocol that makes sense here. Call it serial codable. A lot of times you'll see these able at the end of protocols. So for the serial codable, we want to make sure that the user provides a serial code, and that's going to be a string. It's going to be settable. So to conform to this, we're going to create a class called book, and that book is going to conform to serial codable. We get an error because it's not conforming to it yet, so in order to conform to it, we have to write the serial code here, which is a string, and then we have to provide the init method. Now we don't have to provide the init method. We could just initialize this with a serial code, and then it's going to be conforming to that protocol. Or if we're not going to initialize it, we do have to provide the constructor here, the initialization, and we'd write serial code, and we'd say that that's going to be a string. And then in here, just like before, we would write self.serialCode is equal to serial code. At this point, we can make a new book. We can say var lor is equal to is of type book, or we could just say is equal to book. And then in here, we need to create our serial code. So there's our serial code. And now we have a new book that conforms to the serial codable. If we took that serial code out, it wouldn't conform to it. Now, protocols can require specific instance methods and type methods to be implemented by conforming types. These methods are written as part of the protocol's definition exactly the same way as a normal instance and type method, but without the curly brace or method body. And variadic parameters are also allowed. That's the parameters with the ... But they're subject to the same rule as for normal methods. So let's create a protocol called humanizable. And in order for something to be humanizable, we needed to have a method called eat, which takes 0 parameters and doesn't return anything. We needed to have a method called drink, and drink is going to take a how much parameter, and it's going to be in integers. And let's assume for a second that that's in cups, even though we didn't specify it. And we say that it has to return a Boolean. Now notice that we don't write the curly braces here because we are not writing the actual implementation of the function. Now we can implement or adopt that protocol by making a class called human that adopts the humanizable protocol. Here we can say function eat. Now if you let it code complete, it's going to write function eat for you. And then here we can, if you do control space, we can do the drink method too, and that will write it for you. So we have our function eat. We know that function drink has to return a Boolean. Let's say that we do a print line here, and we're going to say that the human drank how much cups of water. We need to keep that inside the quotes. And then at the end we'll say return true. Then we can have a print line up here that says they ate, the human did eat today. Or let's say the human is eating right now. And then we can create our human, and we could say var Fred is a human, and that's equal to a new human. And again, we don't have to type this, so we can take that out. And we can say Fred.eat, and we can say Fred.drink, and we'll make Fred drink 5 cups of water. And if we open up our console, we could say the human is eating right now. The human drank 5 cups of water. We just need a space there and it'll look much better. So in order to fulfill that protocol, we needed to create an instance method called eat, which took 0 variables. And we also needed to implement an instance method called drink, which you see here. And that took 1 parameter of an integer, how much, and returned a Boolean. Once we return that true or false from the instance method and we implement everything else, our requirements were fulfilled. Also, if you wanted to create a type method and you wanted it to be part of the human, in the protocol you could write a class in front of the function, and that would make it a type method. So then you wouldn't implement that like this, you would implement that like this. And then down here you wouldn't call Fred.drink, you would say human.drink. And then it would be a type method instead of an instance method. So you don't have to just implement protocols in classes, you can implement them in structures, and you can implement them in enums as well. If you needed a structure or an enum to be mutating, you have to make sure that you mark the protocol as mutating as well. Here's a great example straight from the documentation. We'll have toggleable, and this is a protocol that is going to allow a enum to toggle. So we have mutating function toggle, and it needs to be mutating because the enum is going to need to toggle itself. And we didn't go into this in enums, but now we're going to go in a little deeper, and I'm going to show you the power of writing methods within the enum. So this enum is going to be called on-off switch. It's going to be toggleable, and it's going to have 2 cases, the case of on and the case of off. So we have off and on. And now it's requiring that we create this mutating method here. We can do a control space and that will automatically create it for us. And at this point, we're going to do a switch case on self, which means the enum itself, to see whether this enum is on or off. And we're going to toggle it. So if it's currently off, then we will write self is equal to on. And if it's currently on, then we will write self is equal to off. So at this point, you can create a wall switch here, and that's going to be equal to an on-off switch dot off. So now this wall switch is off. We can say wall switch is equal to on-off switch dot off, and it's going to say true. And now we can say wall switch dot.toggle, and that will turn the wall switch from off to on. And now we can say, is it equal to off? False. And we can say, is it equal to on? True, because it switched the wall switch from off, which it was originally at, and it switched it to on. So you know protocols do not implement any functionality, but that doesn't mean you can't use them as a parameter or a return type in a function. And this is when things get extremely powerful and extremely cool. You can also use them as a type of constant or variable or property. It can also be the type for an array or a dictionary. And I'll show you where this gets very, very neat. So we're going to create a protocol called Walkable. And that was a little glitch there. Walkable, you need to provide a name, and we're just making this up here. And that name is going to be get and settable. And you just need to implement a function called walk. And that's going to require the number of steps that you are going to take. When you think about it, you realize that it's not just humans that can walk, it's dogs that can walk, it's cats that can walk. So we can implement many classes that implement this walkable. So we'll create a human first, and we'll say that the human needs to be walkable. And we need to implement our name equals, let's say, human. And then we just need to provide our function, which is walk. And then what we'll do is we'll just do a simple print line, and we'll say the human is walking blank steps. And we'll just tell it that it's steps. And we'll make steps an internal and external parameter. And we could even say the human, even though we know it's a human because we're typing it in here, we could say self.name is walking. So we now have one thing that implements walkable. Let's create one more class that implements walkable. That will be a dog that is also walkable. And we'll say var name is equal to dog. And we'll implement the walk. We will do a print line that says walking the self.name, which is a little unnecessary, but blank number of steps. We'll also implement one more function for the dog, which will be a bark function, and that will just print that the dog is barking. Woof. So now what we can do is we can create a class called playtime. For this class, we can take a function called take a walk, and for that function, what we want is something that is walkable. So notice that if you were to implement this before without protocols, you would have to implement that it's either a dog or a human, or you could use inheritance, but you can also use a protocol. And what's great about the protocol is you know that they're going to definitely have a walk function that you can call. So we know that it's walkable, so this way they can pass in a dog or a human, and we can do a print line, and we can say that we are taking the walkable.name for a walk. We'll call walkable.walk. This is when you start to say this word too many times, it starts to sound weird. Walk, 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 walk. Now what we're going to do here is we're going to allow the dog to bark if they passed in a dog, but if they passed in a human, we're not going to call the bark method because there is no bark method. It'll throw an error. Because if we just said walkable.bark, that's not necessarily going to work because walkable does not have a member named bark. But we want to be able to call walkable's bark method if it was a dog. So what we do is we do what's called downcasting. What we're doing is we're seeing if what they passed in was a dog, and if it is, then we'll make it bark. So what we'll do is we'll do this optional binding here, and we'll say if let dog is equal to walkable as question mark dog. Now what this is saying is it's saying declare a constant named dog and make it equal to walkable as dog. And what walkable as question mark dog is doing, the as question mark is saying is walkable a dog, and it's creating an optional out of this, and it's saying if it is, then create this as an instance of a dog. So down here dog will be equal to a dog if what they passed in was a dog. If not, it'll be equal to nil because this as is with the question mark is creating an optional. As you can probably guess, if you take away the question mark and just did as, that is, if you're positive that what they passed in was a dog, you could take out the question mark. It's not going to create an optional, it's going to force it to be a dog. Then here we can just call dog.bark. So now we can create our playtime is equal to playtime, and we can create a new dog, and that's going to be equal to a dog. and we can say playtime dot take a walk, and the walkable that we're going to pass in is going to be a dog. So at this point you can see that it's taking the dog for a walk, and then you can see walking the dog 10 steps because that's coming from our dog class, and then the dog is barking because what we passed in was actually a dog. If we were to alter this and we were to say playtime and then var human is equal to a new human, and then we say playtime dot take a walk and walkable is set to the human, then it's going to say taking the human for a walk. The human is walking 10 steps. That's coming from the human class, but it's not going to try and make the human bark. When it tries to evaluate this, it's not going to be a dog. We don't get any errors even though we're trying to get the walkable to bark. So the one thing that we're doing that's really interesting, like I said, is called downcasting, which is where you think that the protocol is a dog instead of a human. We check that using the as optional. And at the same time, we assign this to a variable, to the dog constant. And if it works, we now have an instance of the dog inside the if statement. We can also do type checking using is. So if you didn't need an instance of that dog there and you just wanted to do some action, what you can say is if walkable is dog. And what that'll do is that'll just return true or false. It won't provide you the dog instance. So now you could just print line and say was a dog. Then you could do an else and you could say print line was not a dog because it was a human this time. So that's the is and the as, and that's called downcasting and typecasting. What you're doing is you're forcing an instance to be of a certain type, and it'll only work if it can be that type. In Swift, the dictionaries and arrays, they return specific types. In Objective-C, they don't have to be holding specific types. They can contain anything. So a lot of times in the different frameworks and the different APIs that Apple provides, it's common to receive an array with a type called any object, and that's any object. You can see that there. So a lot of times you'll get back an array that returns any object, or meaning an array of values of any type. And like I said, that's because Objective-C doesn't have explicitly typed arrays. But you can often be confident about the types of objects contained in the arrays because of the information you know from the API that provided the array. So you can use any and any object, but you have to know when's the right time to use them. So you can technically create a mixed array here, and that's going to be equal to 3, the string, 2, the number, 1, the number, and let's create a dog here, and a dog. Now normally you can't do that because you think that it's not of a specific type, but what's happening here is this array is going to be of type any. So you can do any. Any can represent an instance of any type at all except for the function types. And any object can represent any instance of any class type. So this can be any or any object, and it's not going to throw an error. So when you do make these mixed arrays and it doesn't throw an error, what you're getting is a mixed array of type any or any object. Without declaring the type explicitly of the array, I cannot guarantee that that array of mixed types is an any or an any object, because I haven't found a way to check the types of an array when it contains mixed variables yet. That's just a side note. So now you can loop through that array and you can say something in that array is going to be of type any in the mixed array. And you could say if something is a dog, remember we did the is before, we can print there was a dog. So you could see that there was one dog here. And we could add one more dog in there, and you can see that there was a dog, there was a dog. When you're working with the APIs that Apple provides and you see something that returns any object, the reason that they did that is because any object as an array can have anything in it, and Objective-C doesn't explicitly type its arrays. Just a side note there. Now we're going to talk about protocols that inherit one another. So we have Walkable above. Now we're going to get a protocol called Exercisable. Exercisable. And this protocol is going to require that you create a function called run, because it requires that in order to exercise you need to run, and it wants to know the number of miles that you ran, and it's not going to return anything. Now the protocol Exercisable, we're going to write that it inherits Walkable. So if we were to implement this Exercisable protocol, we have to implement Exercisable and we have to implement Walkable, because Exercisable is inheriting from Walkable. So in order to do that, we need three things. Walkable has the name property, so we need to implement that. It has the walk function, and Exercisable has the run function, so we need all three of those things. So let's implement Exercisable. We'll call this track star, and that's going to implement the Exercisable protocol. So we need a var name is going to be equal to human. We're going to need a function that's going to be equal to run, and we're going to need another function that's going to be equal to walk, and that needs the number of steps as an integer. So now that we have all three of those things, we've implemented Exercisable. Even though Exercisable only implements one function, because it inherits from Walkable, we need to adopt and implement all three of those things. You may also require that something adopt or conform to multiple protocols at once. This is called protocol composition. So now we'll make one more protocol here, and we'll call it protocol joggable. And that's going to need you to implement the jog method. Miles is a double, and of course we don't implement it. So now if we were to create a function and we call it exercise routine, and we want this to take something that is both walkable and joggable, that implements both protocols, we could write exerciser, and we write protocol, and then we do these less than and equal than signs, and we write that it needs to be walkable, and then we separate it by comma and say it also needs to be joggable. So this exercise routine is going to take both of those, and then we can say exerciser.jog, and we'll say we want it to jog 5.2 miles, and then we can say exerciser.walk, and we want it to walk 5,000 steps. So you can see when we pass something in there that is both walkable and joggable, both of those methods are available to us. And what this does is this creates a new temporary protocol internally that's local to this method, to this function, and that protocol is not permanent. It's just a temporary local protocol. Now you can also mark a protocol as optional. When you mark a protocol as optional, you have to use the @Objective-C attribute. So if we were going to do that, we could say @Objective-C protocol, and this is how you implement something from Objective-C. Even if you're not interoperating with Objective-C, you still need to mark your protocols with the Objective-C attribute if you want to specify an optional requirement. So we have a protocol likable, and that's going to return an optional function called smile, which returns a string. So now we have an optional function called smile. If we take out this Objective-C, you'll see that it throws an error, so we do need the Objective-C in there. And then we're going to have a class called happy emotion, which implements likable, and you can see that it's already conforming to that protocol because the smile function, the smile method, was optional within that likable protocol. But we could still implement it. Function smile takes 0 parameters, returns a string, and we need to make sure that this returns a string. So now if we wanted to create a class of a person again, and we say that this person has a function called walk, let's make him implement walkable so that he has this function called walk. And he needs a property called name, which is going to be a string, which is going to be equal to Fred. Maybe we can make it PHRED, Fred. This walk function needs to take the number of steps, which is an integer, like we normally did. Now we're good to go. Now we're also going to implement a method called current mood. And this is going to take in a likable, which is going to be likable. And you can mark that as an optional because likable has an optional method. So you may or may not get the likable in there because it is optional. And then we can say if let greeting is equal to likable dot smile, and we can print the greeting. This smile also needs to be an optional as well. So then what we can do at the end here is we can say var Fred is equal to a person. Actually, sorry, it's PHRED. Fred is a person. We can create a new happy emotion. We'll create a new happy emotion. And then when Fred is going to walk, keep saying Fred, it's PHRED dot walk. We're going to make him walk 50,000 steps, 5,000 steps. And then we will say Fred dot current mood, and then we need to pass in that happiness. And then we will see that Fred is smiling. But notice that implementation of happiness that we created. Notice that if we took out this function called smile here in the happy emotion, everything will still run. It just won't print out the greeting of the smile that it created because that function smile is optional. And it's going to check if that smile exists or not, if likable has the smile in it or not. What we're doing here is we're checking the current mood. We're passing in a likable. The method in its smile is an optional method. And so we're going to create an if statement to see if it has in fact implemented the smile method. If it has implemented the smile method, then we will print the greeting for smile because we'll get the return of the smile method here and we'll pass it into this greeting constant. And then we will print it. Otherwise, we just won't run this because the smile has not been implemented. Hey, thanks for watching this tutorial on protocols. I know that was a lot of information. It was a very meaty tutorial. Make sure that you go back and review some things before going on. I'll see you next time. Next up is generics.